Good day everyone. This is our assignment for advanced electricity. So today we group 4 will do a presentation about transfer function and dot plot. So first I will introduce our team members who are me, Rajanesh, Kaviraj, Yagendran and Dinesh Naidu. Before we do the presentation. So for the topic we are given, Kaviraj and me, Rajanesh, will do transfer function while Dinesh Naidu and Yagendran will be presenting on bot plot. So Dinesh Naidu will start the presentation.
First of all, we're gonna do a first question, which is question D, transfer function. This is the question, which is 50 j omega over j omega plus 4 and also j omega plus 10 power of 2. Okay, so now we're gonna convert this transfer function to standard form for to do the magnitude dot plot graph. Okay, so now we're gonna start convert the transfer function to the standard form. Okay, first of all, okay, so the reason we're gonna put a fraction which is 4 over 4 and also 10 over 10 and especially 10 over 10 with power of 2 is, first we're gonna change the whole number in the equation, which is 4 and 10 to 1, and also we're gonna, which is we divide with 4 divided with 4 and also 10 divided with 10. For example, if at here have a 6, we're gonna change it with 6 per 6, because we're gonna divide with 6, it will change to 1. Same goes here, it will change to 1. Okay, the reason power of 2 is this equation equals to power of 2. So if we need to divide with this equation, we also need change the fraction to power of 2. Okay, now we're gonna divide this fraction with each equation, which is j omega plus 4 with 4 by 4 and as j omega plus 10 power of 2 divided with 10 over 10 power of 2. Okay, if divide means 4 will be 1 and also jw go with 4, same goes here, 10 will be cut, change to 1, so jw omega over 10. So the equation will be like this. Okay, it will change like this. Now we will simplify this equation, which we will times with 4 and 10 power of 2, which will be 400, and we will divide with 50. Okay, which will be 0.125. so then only we can get a complete standard form for do the graph magnitude dot plot. Okay, so it will be j omega over 4 plus 1 and 10 plus 1 will be 400, because of we gonna multiply with 10 power of 2. If 10 power of 2 equals to 100. Okay, so next step, as I say, we're gonna divide 50 with 400, which gonna be 0.125 j omega, and other will be remain same, which j omega 10 plus 1. So this is the standard form for this transfer function, and also we will use this standard form to do the graph for magnitude word plot. Before that, we're gonna identify the basic terms of transfer functions. Okay, first thing, 0.125 we will use for gain. J omega we gonna use with 0 at origin, and this gonna be simple pole, and this also gonna be simple pole, but we also can define as double pole. The reason is we got this equation got power of 2. If they are not power of 2, we can call as a simple pole. If we got a power of 2, it will be double pole. Okay, same goes here. We do not have a power of 2 at these equations, so we can call it as a simple pole. The reason we call a 0 at origin, the numerator we will identify as a 0, and denominator will be identified as a pole. Whatever for example, this j omega over 4 plus 1, we keep at numerator, we will call as simple 0. Okay, so that's why we identify this j omega 0 at origin. Okay, after this my teammate will explain about the graph and also how to do the graph. Okay,
hello everyone, today I am going to explain how to sketch the word plot graph. Before we sketch the graph, we need to understand the standard form, which are gain 0 at origin j omega, pole at origin 1 over j omega, simple 0 1 plus j omega over z, and simple pole 1 over 1 plus j omega over p. For gain, which is a straight line, and its formula is 20 log k, and for the 0 at origin, we have to increase 20 dB per decade, and for the pole at origin, we need to decrease 20 dB per decade. For simple 0 is also same like 0 at origin, increase 20 dB per decade, but there is a flatter area before we increase it. Same as simple 0, there is a flatter area before we decrease 20 dB per decade for simple pole. Now we sketch the graph. As per the calculation, we have 0.125 j omega over j omega over 4 plus 1, and j omega over 10 plus 1 power of 2. So first we need to sketch the gain line. So gain formula is 20 log k. We already got the k, so we substitute it as 0.125, which we will get negative 80 dB. So we sketch it at negative 80. Then we label it 20 log 0.125 equals to negative 80 dB. Then we have j omega, which is 0 at origin. J omega is increased in 20 dB per decade. So we have only one j omega, so we plot at 1, then at 10, at 20, increase in 20 dB, because 20 dB per decade. This is a decade and this is dB. So we sketch, then label it as JW. After that we have j omega over 4 plus 1, which is 1 over j omega over 4 plus 1. This is a simple pole. For simple pole, we would decrease in 20 dB per decade. So there is a 4 in it, so we plot it at 4. If we take 4, then we have to take 40 also, because it is a decade. Because of it's a simple pole, we need to decrease in 20 dB, so we plot a point here. Let's sketch a straight line. Okay, then label it as 1 over JW over 4 plus 1. Now we have j omega over 10 plus 1 power of 2, which is same as simple pole but with the power of 2. It can be confusing for some, but it is simple as simple pole. Just like the simple pole, we have to decrease it, but we have to decrease it by 40 dB per decade. So there's a 10, so we have to plot it in 10. Then just like the simple pole, we have to take the decade, which is 100, but we have to decrease 40, so we plot it here, then sketch, then label it as JW, 1 over j omega plus 1. Okay, so this is how it looks like in the original Bode plot graph. So we have the gain straight line, the 0 at origin, simple pole and double pole. Now we have to sketch the critical line. So for point 0.1 we have negative 20 and negative 18. So we plus 8, negative 20 plus negative 18, we get negative 38. So we plot it negative 38. Then at decade 1 we have negative 18 and 0, so which is negative 18, so we plot it here. Then at decade 4 we have negative 18 also, we have negative 18 and we have 12, 10, 12. So we plus 8, we get negative 6. So 2, 4, 6. Then at decade 10 we have negative 18 also, negative 8, 0 and 20. So we plus it also, negative 18, negative 8, 0 plus 20. We have negative 6. We plotted at negative 6. Then for lastly for decade 100, which we have negative 40, negative 28, negative 18 and positive 40. So we plus it, negative 40 plus negative 28, negative 18 plus the 40. We have 46, which is okay. Then we just sketch it. After that, we label it as critical point. Then it is look like this. That's all from me. Thank you.
Hi everyone. Today I'm going to teach you about magnitude dot plot. So I'll teach you on how to find the gain, simple zero, simple pole, and finally how to construct a transfer function. So let's get started. So this is the given graph to me to find some values. So as you can see, this is the critical line of the graph. So we have, I will separate it into few parts. This is part 1, part 2, part 3 and part 4. So first, let's determine the value in part 1 what we can get. So we can get from here is 20 dB. So this is the gain, 20 dB is the gain. So to find the gain constant, we need to use the formula 20 log K equals to 20. This 20 is from here. So K equals to shift log. When we do shift log in the calculator, we should get shift log 10 to the power of 20 over 20. So we got 10. So this is the gain constant. So next, as we can see, I'm going to find in part 2, we can see that there is a slope plus 20 dB per decade. Based on the factor of dot plot, we know that if there is a slope like this, that means the formula should be 1 plus j omega per, as we are finding the value for omega 10. So not omega 10, 10 radian per second. So it's over 10. Right. So for the next part, I have done part 1 and part 2. So next is for part 3, which is 100 radian per second. So for 100 radian per second, before this 100, there is an increase in slope plus 20 dB. After 100, the slope remains flat. So based on the factor of a dot plot, we know that if there is a slope that is flat and decreased by 20 dB per decade, we will do part 3 and part 4 together, because based on the factor, if there is a slope like this, we can know that there is a simple pole, which is 1 over 1 plus j w over, first we will do for 100 radian per second. So 100. For 1000 is the same formula. So 1 over 1 plus j omega over 1000. So that is the four things we can find from this plot, which is the gain constant, the simple zero, and two simple pole. So that's all from me. Thank you.
In this video, I'm going to talk about how to transfer standard form to transfer function. So let's move on. So in the previous video, my friend explained about the Bode plot. So from the Bode plot, we know that the gain is 10 and simple 0 is jw over 10 plus 1. So in the denominator we will write jw over 100 plus 1, which is simple pole, and there's another simple pole too, which is jw over 1000 plus 1. So this is the standard form. So now we are gonna change it to transfer function. So let's move on. So after this, 10 jw over 10 plus 1. So I'm gonna multiply with 10 over 10 because the number is 10, so it's easy to cancel out. Okay, so in the denominator I will write jw over 100 plus 1 multiply with 100 over 100. Here jw over 1000 plus 1, 1000 over 1000. Okay, so after this let's multiply in, so which will be like this. So jw over 10 times 10. So you know why I wrote 10 over 10 here, so then it will be easy to cancel. So there will be just j omega value there. So plus, sorry I forgot to put a bracket here, so times 1 over, times 1 times 10. So in the outer part I will write 1 over 10. The denominator I will write j omega over 100 times 100 plus 1 times 100. So here I will write 1 over 100. So after that, j omega over 1000 times 1000 plus 1 times 1000. So here I will write 1 over 1000. So now it's easy to cancel out 10 over 10. So it will be like jw 1 times 10 is equivalent to 10, so jw plus 10. Here I will write 1 over 10. So in the new denominator I will write jw. So here we can cancel. So the remaining is will be j omega plus 100. Here I will write 1 over 100. So for this one, cancel out 1000. So the remaining will be j omega plus 1000. Here I will write 1 over 1000. So after this, we can cancel out 10 and 1 over 10. So which is equivalent to 1 j omega plus 10 over j omega plus 100, 1 over 100 j omega plus 1000, 1 over 1000. So now I will multiply these two. The value will be 1 over 100,000. So here will be 100,000 j omega plus 100. Here would be j omega plus 1000. So now I'm going to take this 1/1000, multiply with 1. So the answer will be 100,000 j omega over 10, j omega plus 10, sorry, over j omega plus 100 and j omega plus 1000. So in the final stage, this j omega I've substituted into s. So the answer will be 100,000 s plus 10 over bracket s plus 100 close bracket open bracket s plus 1000. So this is the final answer. Thank you very much.